Let's do classwork 7 together. Classwork 7 needs some sort of introduction because it was not on my plan to make classwork 7 this one. The idea of classwork 7 was the question of one of our classmates that he asked in the modeling strategy that we have, we assume that the things coming from quarter one after production can go anywhere in the coming quarters. For example, when X15 is manufactured, some of it being used in the first quarter to satisfy the demand of 400, but the rest goes to the next quarter. But we cannot specify, we couldn't specify how much of that X15 gonna be used in quarter 2, in quarter 3, and in quarter 4. Our classmate asked me if it is possible to model it in a way that we can track all the things. For example, we can say exactly how much of X15 that we have manufactured going to quarter 2, how much going to quarter 3, and how much going to quarter 4. Again, I'm gonna emphasize with the previous modeling, that is the modeling in your textbook, it is not specified. The only thing that is important is how much we have to manufacture carpet, how many or the amount of carpet that we are manufacturing in quarter 1, and how much of it going to be used in quarter 1, and how much of it going to be used in the following quarters, either quarter 2, either quarter 3, and either quarter 4. His question was a wise question, so I decided to share the challenge with you as a classwork, because you know every details about this problem, so you are not going to spend any time on understanding a new problem, and the challenge would be a good one. When you do the new modeling, you can test its correctness by solving it, and the result must be 100% the same with the previous one. So we start with activity 1, that it says in the model we did last week, we had no control over the exact amount of carpet that is, for example, sent to the quarter after next quarter. That is the things that I just described. We just control the amount of carpet that is sent to the next quarter to be used for the following quarters. According to the new scenario, draw the graph that can control the exact amount of carpet that is produced for the specified following quarters. And another point that I want to mention, since it is a classwork, please be more patient regarding the activities and pause your video and put a good time on it until you come up with a graph. In fact, you are drawing the model that can show the exact amount of carpet that goes to the following quarters. It is not just drawing a graph, my friends, because in the previous situation we had the model and we drew the graph accordingly. But here you need to think about it more, that how you can do it. It is the graph that you should come up with, or maybe you have developed some other type of graph. But there are many ways, and now you can see I'm just doing another modeling according to your classmate question. So if you are interested and you believe your model is right, or you have any question, for example, if you noticed your model is not correct, feel free to contact me. We can discuss it through Zoom meetings. So here is one. As you can see, we changed the model in this way. I removed this part, so the amount that we send to the next quarters, it is not of any interest to us because we want exact amount. It is important for us to see how much we produce to use for this quarter, how much we manufacture to be used for the next one, and like that you see. So we have X15, X16, X17, and X18. One point that you have noticed here is this 2.25. Why, if you want to manufacture in quarter one and send it to the next quarter, per unit you need to pay $2.25, because $2 for production at quarter one and 25 cents for storing. When you are manufacturing in quarter one to be used in quarter three, you need to pay 2.5 because you have 2 quarters of storing. So $2 plus 50 cents. The same logic is used to come up with 2.75. The same thing we continue for quarter two, quarter three, and for quarter four. Since everything that you manufacture in quarter four is going to be used in quarter four, we have only X48. So it is our new graph. Withdrawing the graph according to what I just described, you have achieved the majority challenge of this activity. I don't know if I was right with my sentencing, but I wanted to say that the most difficult part, the most challenging part of this case is done now, because after that it would be just writing the mathematical formulation. Here it asks you to define the new set of decision variables according to this. Okay, pause the video before you see the answer. Totally, we have 10 decision variables: x15, x16, x17, x18, x26, and like that. But the description that is always very important in mathematical modeling. X15, as you can see, it says the amount of carpet produced in the first quarter for the first quarter. X16, the amount of carpet that is produced in quarter one but transferred to quarter two for use in quarter two. See how much it is clear. X17, the amount of carpet that is produced in quarter one but transferred to quarter three for use in quarter three. It is specified clearly that the amount of carpet that is produced in quarter one but transferred to quarter three is not for use in quarter four. Why? Because we want to have 100% control over the specification. In the next activity, it asks you to write down the objective function. Pay attention. When you are writing the objective function, similar to the previous cases that we have had so far, all the decision variables must be involved. 10 decision variables. And pay attention. For example, if you are writing the decision variable x16, the associated cost is $2.25. Pause the video, write the objective function before you check the answer with the video soon. Here we have the objective function with the same logic. We discussed it before. And after that, we go for the constraints of the supply nodes. Constraints of the supply nodes is similar to all the previous supply nodes we have had so far. Pause the video before you check the answer. We have 4 supply nodes, so we have 4 supply constraints. For example, for quarter 1, it is the capacity 600, and it is the outflow X15, X16, as you can see here, X15, X16, X17, and X18. All of these things must be equal or smaller than 600. The same description, elaboration applies to these things. For the last one that you can see, X48 is equal or smaller than 400 because we have only one outflow from this node, and the capacity of quarter 4 is 400, so X48 is equal or smaller than 400. Here you are asked to define the new sets of constraints regarding the demand nodes. Similar to the previous ones, you check here and the demand is 400, and remember, these things are demand nodes, so the sign you must use is, or I should say should use, is equal. Pause the video before you check the answer. We have 4 nodes, 4 demand nodes. Therefore, we must have 4 demand constraints. For the first one, as you can see, we have only one inflow and 400 is the demand. So X15 must be equal to 400. For the next one, as an example, I'm gonna explain it. On the outflow is only 500 because anything that you manufacture for quarter 2 must be used in quarter 2. There is no outflow to any other quarter. So we have X16 plus X26 equal to 500. When you add the non-negativity constraints to the previous constraints that you have developed, the last activity is asking you to solve the model with Excel. The results that you get, of course, since the decision variables are different, is different from the answers you got from last week model, but the meaning is completely the same. The numbers are different, but everything is else the same. Let's check it together, but before you check the answer, first you finish your Excel solver and check your answer with the results, because when you do it with solver yourself and you check it before, it helps you understand the problem much better. It is the result of solver. As you can see, the objective function is exactly the same, but the numbers are different. But when we check it here, we notice the answer, in fact, are the same as last week, just the presentation is different. For example, here it says that X15 is 400. X16 is 200. X26 300, 37 400, and X48 400. Everything makes sense because you see in quarter 1 they manufacture 400 for the demand of quarter 1, and they use the remaining 200 capacity of quarter 1 for the next quarter. In the next quarter, quarter 2, 300, because 200 from the previous quarter and 300 from quarter 2, so 500 is satisfied. In quarter 3, 400 out of 500 capacity to satisfy this 400, and since 3 and 3 here are the same, there is no need to manufacture in quarter 3 for quarter 4 because they have enough capacity and the price is the same. As you have noticed, the only difference with the last week answers that we got is here, because in the last week X15 was 600. That meant the amount you manufactured in quarter 1. But here again, the amount you manufactured in quarter 1 is 600, but it is specified that 400 for quarter 1 and 200 for quarter 2.